Good morning, students. Yesterday, I told you I will be starting with the calculus portion. So, I am right now starting with tangents and normals. As you have already told me that successive you have already studied and you know also Leibniz theorem. So, let me start with tangents and normals. You see, you have already studied tangents and normals. You know how to find equation of tangent, equation of normal, then length of polar tangent, length of polar normal, subnormal, or length of polar subtangent, and etc. For the curve y equal to fx means for coordinates coordinates you have already studied tangents and normal. Now here I will be starting tangents normal for polar coordinates, and you know what are the polar coordinates? R and theta. These are known as polar coordinates, and the curve is r equal to f of theta. This is the polar curve. Likewise, y equal fx, it represents a curve in terms of Cartesian coordinates x and y, and in terms of r and theta, it is known as the polar curve or polar coordinates are these r and theta. So let me start with first article. You have to find the angle between the tangent and the radius vector. For the curve r equal f of theta. This is our first article. It means that if you have a curve, this is the curve r equal function of theta. And what is r, what is theta? I will be just explaining. Say this is the point P on the curve P r theta. Let this be the origin O. This is known as pole. Distance from pole up to the point is known as r, the radius vector, right? And the angle between the radius vector and initial axis is known as theta. So r and theta, relation between r and theta, this is the polar curve, polar coordinates. These are the polar coordinates. Now, what I am supposed to find is that find the angle between the tangent. I have to draw a tangent over here, PT. I have to find angle between the tangent and the radius vector. Means I have to find this angle. This is the angle denoted by phi. I have to find the angle phi between the tangent and the radius vector, and I know this angle is given by tan phi equal to r d theta by dr. This thing is our first article, and we will be just proving this article first. Okay, let me start now proving this article. So I have a curve represented by r equal to f of theta. This is pole, this is the point, this is OP, this is known as the radius vector r. This is theta, here it is theta, the angle between radius vector and the initial axis, and this angle, I have to find the angle between tangent and radius vector. Now, how I will proceed? Let me suppose that Q, r plus delta r, theta plus delta theta, be a neighboring point of this P, be the neighborhood of P. Then let me join OQ. Likewise, OP was R, the OQ will be R plus delta R, obviously. And what is the total angle? This point makes with, this line makes with the initial axis, it is total angle is R plus delta theta. So this angle will be only del theta. So that whole angle is theta plus del theta. So this is PR theta, this is R, this is theta, this is Q, R plus delta R, theta plus delta theta. So this will be R plus delta R, and this whole angle will be theta plus del theta. Now what I will do, this is, as you know, you have already studied such things. This is in the neighborhood. This is very close to P, and this will act as a straight line, not a curve. So let me draw a perpendicular PL on this line OQ, and let me suppose that this is my angle alpha. Fine. Now from this triangle, see, I have now two triangles. This is a triangle PQL or LPQ LQP, and this is another triangle PLO or POL or LOP. Okay. Now let me take up this triangle. From the triangle PQL, what I have? I have tangent of alpha. What is it equal to? Perpendicular by base. It is PL by QL. Clear? This is the perpendicular, this is the base, and this is the hypotenuse, right? So tan alpha will be PL by QL. But what is this QL? This is nothing but this is OQ minus OL. So this is PL OQ minus OL. Fine? This QL, only this portion will be full portion minus this portion. Okay, fine. Now what is this OQ? This is R plus delta R. So this is PL R plus delta R minus OL. This is my 1. Let me call it 1. So there are two unknowns in 1 now. PL and QL. This is PL, this is OL, sorry, not QL. This is R plus delta R, OQ is R plus delta R. Now I will try to find this PL and OL in order to find the angle phi between tangent and radius vector. What I will do, now I will take up this triangle now, this one. Now from triangle POL, what is sine of del theta? Because angle is del theta. In this triangle, the angle is del theta. Sine del theta is what? Perpendicular by hypotenuse. It is PL by hypotenuse. So it is OP. So it is PL by R. Means your PL is R sine of del theta. Quite clear. Your PL is R sine del theta. What about cos del theta? It is base by hypotenuse. So this is the triangle, this is the base. What is base by hypotenuse? Base OL by OP. So OL by R means your OL is R cos del theta. So I have both of the things, PL as well as QL. My PL, which I need here, is R sine del theta, and OL is R cos del theta. So let me substitute the values of PL and QL on OL in 1. So therefore from 1, I have tan alpha equal PL, it is R sine del theta, R plus del R minus R cos del theta. Clear? This is PL and this is OL. Now, this can be written as R sine del theta. This is R 1 minus cos del theta plus del R. Fine? Good. Okay. This is further equal R. You know, sine of theta is sine 2 theta by 2. It is, what is sine 2 theta? It is twice sine theta by 2 cos theta by 2. Or I will take one more approach. This is sine del theta divided by R. What is this? 1 minus cos theta. This is twice sine square del theta by 2. 1 minus cos theta is twice sine square theta, and this is del R. Now let me divide numerator as well as denominator by delta r. So tan alpha r is equal r sine del theta by del theta. Let me divide and multiply. So divide numerator and denominator by del theta. So this is sine del theta by del theta divided by r twice sine square del theta by 2 divided by del theta plus del r by del theta. Actually, it is r twice sine square del theta by 2 plus del r divided by del theta. So I have taken them separately. What I will get now? This is r sine del theta by del theta. As you know, sine theta by theta is 1. I will be using it. This is 2i r. See, this is sine square. So it is sine del theta by 2 and sine del theta by 2. Okay, this is sine square. Fine. This is del theta over here. Okay, whether you take whole or this one. And this is 2. Let me take it here. So twice sine square del theta by 2 I have written as r sine del theta by 2, sine del theta by 2, then del theta, and this 2 is in the numerator. Then what remains is del r by del theta. Fine? Okay. Now we have 2 now. See, you know limit theta approaching 0. Sine del theta by del theta, or theta by theta rather. Sine theta by theta is 1 always. I will be using this. For that, what I will do, I have to find angle at what? Angle between tangent and radius vector at point P, because tangent is at the point P. What I will do, I will, this is the point r delta r, theta and del theta. In order to find angle at P, I have to recite Q to P. So taking limits as Q approaching P. Taking limits as Q approaches P. When Q approaches P, in that case, alpha will approach to phi. See, this is actually angle between tangent and radius vector. This is in the neighborhood also. That is why this alpha will approach to phi. So let me take limit as Q approaches to P. In that case, delta theta will be 0. When delta theta will be, means del theta is 0. So I will get from, say, if this is 2, I will get tan of, instead of alpha, I will get phi. Is limit del theta approaches 0, this whole thing, or sine del theta by del theta, or sine del theta by 2, del theta by 2, sine del theta by 2 plus del r by del theta. What is this equal? This is nothing but, this is 1, or this is 1, but sine 0 is 0, so this is 0, and this is dr by d theta. So this is r d theta by dr. So I have tan phi, angle between the tangent and radius vector, equal r d theta by dr. This is my first article which I will be using in order to get angle between the tangent and radius vector. I hope you understand. Only this point, maybe you may need some clarification. We can discuss it in our class also. Fine? Okay, now let me come up with another article. Okay. You see, maybe instead of one curve, we have two curves. Say you have a curve and this is the point P, r theta, and this is the pole, this is r, and this is angle theta, sorry, angle phi, angle between tangent and radius vector, and let me call this now phi 1. This is first angle, this is the curve, one tangent and one radius vector. Now let me suppose that through this point another curve passes. So let me suppose that another curve crosses through this point. Then at this point there will be another tangent. Say this is the tangent. This was tangent 1. This is say tangent 2. Then what is the angle? This is the angle between tangent and radius vector. First angle was this one. Angle between radius vector and tangent. Second is bigger one. Tangent and radius vector. This is say phi 2. So obviously there is something common between phi 1 and phi 2. That angle is known as angle of intersection. Angle of intersection, denoted by alpha. This will be phi 1 minus phi 2 if obviously phi 1 is greater than phi 2, or this can be phi 2 minus phi 1 if phi 2 is greater than phi 1. Fine? This is quite simple. You have two curves. You have this radius vector is common. Radius vector is common. You have one tangent, so you have one angle, phi 1. You have another curve, you have another tangent. This is the radius vector. You will have another angle, say phi 2. So there will be some portion common to both phi 1 and phi 2, which is known as angle of intersection. Fine? So one thing is I have to find angle between radius vector and tangent. Second, I have to find the angle of intersection between radius vector and between the curves. Angle of intersection between the curves. So let me now come up to polar tangent, polar subtangent, polar normal and polar subnormal, which you have already studied in your 12th class. For the curve y equal fx, Cartesian coordinates only, I will be discussing it for the curve r equal f theta. Okay, now find the lengths of polar tangent, polar subtangent, polar normal and polar subnormal. To the curve r equal f theta. Otherwise, you are familiar with the case finding the tangent, subtangent, normal and subnormal to the curve y equal fx. I have used the word polar, means I am discussing the curve r equal f theta. Fine? So let me take up this one. See. Let this be the curve r equal f of theta. Okay. Let me suppose that this is the point P r theta on this curve. Let this be the pole. So you know this OP is r. Fine. Now let me suppose let me draw a line which is perpendicular to this radius vector. Let me draw a line which is perpendicular to the radius vector. Now, let this be the tangent to the curve at point P, which meets this line at T. Then you know PT is known as polar subtangent, right? From pole to tangent, this is known as, this is polar tangent. polar tangent. As you know, this is tangent, right? PT is the tangent to the curve at point P, so this will be polar tangent. But from distance from pole to tangent, it is polar subtangent. Fine. Now normal. What is normal? Let me draw PN perpendicular to the tangent. This is PN, which meets this line at N. Then obviously PN is polar normal. See, this is normal to the curve, perpendicular to the tangent. This is normal. You know this. From pole to normal, this distance is known as polar subnormal. Fine. I have to find the lengths of polar tangent, polar subtangent, polar normal, and polar subnormal. Fine. This is it. Now I know this is the angle phi between the tangent and the radius vector. Fine. And what about this angle? Total angle is 90 because this is normal to the curve. This is tangent to the curve. This is normal to the curve. So this angle will be 90. Then what about this angle? This will be 90 minus 5. Fine. I don't think there's any problem in understanding this. This is normal to the curve. Whole angle is 90. This is 5. So this angle will be 90 minus 5. Now let me take up this triangle. And angle is 5. What about tan phi? Perpendicular by base. This is perpendicular by said that this is perpendicular to the line. Perpendicular by base. So OT by OP. So OT by R. Your OP is R. So your OT is R tan phi. So length of OT, polar subtangent, is R tan phi. But we know tan phi is R d theta by dr. So OT, length of polar subtangent, is equal to R square d theta by dr. You have to remember it once for all. Length of polar subtangent is R square d theta by dr. Fine? Okay. Now from this triangle only, what is cos of phi? Base by hypotenuse. Your base is OP. Your hypotenuse is PT. So OP is R by PT. So what about PT? PT is R by cos phi or R secant phi. Fine? R secant phi. Length of polar subtangent, you know, polar subtangent is R square d theta by dr. I will be using it finally. Okay. Now your PT, length of polar tangent, it is R secant phi. What is secant? Secant is 1 plus tan square phi. You know, secant square minus tan square is 1. So secant square is 1 plus tan square. But what is tan phi? Tan phi is R d theta by dr whole square. So PT, length of polar tangent, is R under root of 1 plus R d theta by dr whole square. Remember it once for all. Now we are finished with this triangle. Now we will be taking up this triangle, and I will be using this concept only. I will be finding tan 90 minus phi and cos 90 minus phi. Now from the triangle OPN, what is tan 90 minus phi? Perpendicular by base. This is the perpendicular. ON by base, your base OP. So ON by R. So your ON is R tan 90 minus phi. What is tan 90 minus phi? You know, it is cot. But what is cot phi? It is 1 by tan phi. And what is tan phi? R d theta by dr. So this is nothing but dr by d theta. So length of polar subnormal is dr by d theta. Remember it once for all. Length of polar subnormal, sorry, ON, polar normal, yeah? ON, polar subnormal. Length of polar subnormal is dr by d theta. Now I have to find only length of polar normal. For that I will be using cos of 90 minus 5. Now from same triangle, from this triangle OPN, cos of 90 minus 5 base by hypotenuse OP by PN, R by PN. So cos of 90 minus phi is sine phi, R by Pn. So what is Pn? It is R by sine phi. It is R cosecant phi. Fine? This is R cosecant phi. Now what is cosecant phi? It is 1 plus cot square phi. But what is cot? It is in terms of tan. So length of polar normal is R 1 plus 1 by R dr by d theta whole square. So remember lengths of each polar tangent. Length of polar tangent is polar tangent R1 plus R d theta by dr whole square. Polar normal R1 plus 1 by R dr by d theta whole square. Polar normal dr by d theta, and polar subtangent it is r square d theta by dr. Fine? You have to remember all these things. I'll be now taking up questions. Rather, we have one more article. Let me finish that also. So we'll be finishing with tangent and normal. Tangents and normals. I have to find, this is another article, is pedal equation. Pedal equation. Pedal equation is relation between P and R. What is P and what is R? R, you know, it is the length between radius vector. This is a radius vector. This length between the pole and the point. And P is the perpendicular distance from the pole upon the tangent. This is it. This is tangent to the curve. Sorry. PR theta. This is tangent. Fine. This is pole. OP. This is R. Now this was the initial axis. Now this is not the initial axis. This is perpendicular from the pole upon this tangent. This is known as P. Say PL. This is small p. Length, perpendicular distance. This is perpendicular distance from O upon tangent. And this, you know, this is what? This is phi. I have to find pedal equation. What is the pedal equation? Pedal equation is given by P equal to R sine phi. A relation between P and R is known as pedal equation. Just like relation between R and theta is known as polar equation, relation between x and y is known as Cartesian equation, relation between P and R is known as pedal equation. Fine? So from this I can get sine phi, perpendicular by hypotenuse. This is perpendicular. OL by hypotenuse, OP. What's OL? OL is P and your OP is R. So P is equal to R sine phi. This is known as pedal equation. One more form of pedal equation is that you can see P is R sine phi, whatever 1 by P. Or let me suppose what is P square? P square is R square sine square phi. So 1 by P square will be 1 by R square sine square phi. So it is 1 by R square cosecant square phi. But cosecant square phi, you know, it is 1 plus cot square phi. And cot, you know, is tan in terms of tan. We can write it in terms of tan. So 1 by p square is 1 by r square, 1 plus 1 by tan square phi. And you know what is tan phi? It is r d theta by dr. So it is 1 by r square, 1 plus 1 by r square dr by d theta whole square. Or 1 by p square is equal 1 by r square plus 1 by r4 dr by d theta whole square. This is another form of Peter equation. Fine. Whether you use this formula or this formula, both are Peter equations. So let me now come to the questions. Okay. Now question is, I have to find first article. I have to find the angle between tangent and radius vector. Let me take up a question. Say r square equal a square cos of 2 theta. Say theta is pi by 6. Find the angle between tangent and radius vector. You have to find angle between tangent and radius vector. Means you have to find phi. Phi is to be found out. And you know what is tan phi? Tan phi is r d theta by dr. So you need d theta by dr. You have r and theta. So let me differentiate with respect to theta. 2r dr by d theta is minus 2a square sine 2 theta. So dr by d theta is minus a square sine 2 theta by r. Fine. Now what is tan phi? Tan phi is r d theta by dr. Since this is dr by d theta, you need d theta by dr. So this is r by minus a square sine 2 theta. So tan phi is minus r square by a square sine 2 theta. But what is r square? It is minus a square cos 2 theta by a square sine 2 theta. So tan phi minus cos by sine, it is cot 2 theta. And what is minus cos theta? Minus cot theta, it can be written as tan 90 plus theta, right? Tan 90 plus theta is cot, minus cot. Tan minus pi by 2 minus theta is cot. So minus cot is tangent of 90 plus theta. Instead of theta, you have 2 theta over here. So what is phi? Angle between tangent and radius vector is, this is the angle between tangent and radius vector. If theta is given, you can find full, what is it? 2 theta, then 2 theta by 2, 2 pi by 6. So pi by 2 plus pi by 3, 6, it is 5 pi by 6. Fine? Oh, sorry. 2 into 3. 2, 3. How you, okay, this is 2, 3, 6. 2 into 2, 3. Okay, this is it. It is 5 pi by 6. If theta is pi by 2, pi by 2, pi by 2 plus pi, you will get another phi. But then angle will be different. Fine? So this is the way you have to find the angle between tangent and radius vector. There will be questions or function of theta. You will be given theta. If it is not given, you can find in terms of theta only. If it is given, you can find the exact value. What is the angle? Okay. Now let me take up one more question. Say r is power m, a is power m cos theta minus sin theta. at theta equal to 0, say, or you can take any angle. So this is r is power m. I have to find tan phi. For that, it is r d theta by dr. So I have to find dr by d theta. So let me differentiate with respect to theta. What is that? M r is power m minus 1 dr by d theta. It is power m. Well, what is differential of cos? It is minus sine. Minus sine theta and cos theta. You see, differential of cos is minus sine. That of sine is minus cos. So minus I have taken already outside the bracket. So this is dr by d theta, or your dr by d theta is minus it is power m sine theta cos theta by m r is power m minus 1. Now what is tan phi? It is what you can take in order to get rid of this m. If you take m over here, cos m theta, okay, doesn't matter, it doesn't matter. It is r d theta by dr. So m r is power m minus 1 minus it is power m sine theta plus cos theta. This is nothing but r is power m. Substitute r is power m. This is minus m. It is power m sine theta cos theta minus sine theta minus it is minus I have taken here sine theta plus cos theta. This goes, so tan phi is nothing but cos 0 is 1, sine 0 is 0, so it is minus m. We can take phi as tan inverse minus m. If I would have taken a only instead of m, a raised power m, m would have been 1, this would have been minus 1. A particular case I am discussing. Tan phi is minus 1. What is tan pi by 4? It's 1. So it would have been minus tan pi by 4. So minus tan pi by 4 can be made into plus. You know, minus tan theta is tangent of pi minus theta, right? So you can take every possibility is there. Whatever theta is, how theta has been defined, so you can take all these possibilities are there. Okay, now let me take up one more question. Okay, find angle of intersection between the curves r square equal a square cos 2 theta and r equal a1 plus cos theta, right? Okay, in fact you have to show that angle between, oh, this is a bit lengthy question. Let me take up, this is one, let me take up one more question. R equal a1 minus cos theta, r equal a1 plus cos theta. This is another question. Let me take up first this question. This is very easy. This is 1, this is 2. Now see what I have to find. I have to find the angle of intersection. For angle of intersection, you know angle of intersection alpha is phi 1 minus phi 2 or phi 2 minus phi 1. So I have to find phi 1 as well as phi 2. For this curve I can have phi 1. For this curve I can have phi 2. But before that I can find angle between these two, this theta angle theta between 1 and 2. How? This is r, this is also r. So from 1 and 2, a1 minus cos theta is equal to a1 plus cos theta. right? A cancels out, 1 and 1 cancels out, so 2 cos theta equal to 0, means cos theta equal to 0, means cos theta is cos pi by 2. A particular case, so theta is pi by 2. I have taken theta as pi by 2. Cos 3 pi by 2 is also 0, so theta is pi by 2. Let me take one more. 1. So now I know what is theta. Okay. Now I have two curves, R and R. Let me find phi 1 for this or phi 2 for this or whatever you like. So let me differentiate with respect to theta. What I will get? dr by d theta. It is a sine theta. Derivative of minus cos is plus, minus sine, so minus is plus. Now tan phi 1 r d theta by dr. What's r? A 1 minus cos theta by a sine theta. These chalks are not good. Now 1 minus cos theta is twice sine square theta by 2. Sine theta, this is twice sine theta by 2. Cos theta by 2. So this is tan theta by 2. So what is phi 1? It is theta by 2. You know what is theta. Theta is pi by 2. You can take it, either you substitute it here or you can substitute it later. Now for this curve, dr by d theta is minus a sine theta. Tan phi 2 is r dr by d theta. Fine. Twice cos square theta by 2, 2 sine theta by 2, cos theta by 2, minus cot theta by 2. Minus cot in terms of tan, it is tangent of 90 plus theta by 2. So what is phi 2? 90 plus theta by 2. Which one is bigger, phi 1 or phi 2? Obviously phi 2 is bigger. So my alpha will be, obviously, angle of intersection. Alpha is phi 2 minus phi 1. That is pi by 2 plus theta by 2 minus theta by 2, which is only pi by 2. So no need to substitute value of theta. If it would have been in terms of theta, then you would have substituted the value of theta. Okay, now you have one more question. This was a bit tricky, so I choose this question rather than this question first. Now let me find the angle of intersection for these two curves, and it is given on the book. You have to show that angle of intersection is, I think, I don't remember, it's 3 sine inverse 1 by 4 raised 3 by 4 is, or 3 by 4 raised power 1 by 4, or yes, like that, 3 by 4 raised power 1 by 4, like this. This is the angle of intersection between these two curves. Now let us see how this is equal 3 sine inverse 3 by 4 raised power 1 by 4. Or there may be some mistake, some correction that can be done. Okay, now I have two questions. For r equal to 1 plus cos theta, I know what is phi 2, right? I will not be, and I know for this curve also. Because both these questions have been solved. Let me find theta first. This is 1, this is 2. From 1 and 2, this is r square, this is r. From 1 and 2, you have a 1 plus cos theta whole square. R square equal to a square cos 2 theta. Okay? In our previous question, I was having r and r, so I just equated them. Now I have r and r square, so I have to substitute r square. This is a square, which will cancel out. A square plus b square, a plus b whole square, plus 2ab cos 2 theta. It is twice cos square theta minus 1. Fine. This is 2 cos square minus cos square, this is cos square theta. I have taken this on this side. 2 cos square minus 2 cos theta. Taken this one only on this side. So minus 2 equals 0. This is a quadratic equation in terms of cos theta. So I will get cos theta equal minus b under root of b square minus 4ac by 2a. This is 12. 4 into 3. This is 2 plus minus 2 root 3 by 2. So cos theta is 1 plus minus root 3. So either cos theta is 1 plus root 3 or cos theta is 1 minus root 3. Now you know cos cannot be 1 plus root 3 because value of cos and sine lies between minus 1 and plus 1. This is less than 1, so cos theta will be 1 minus root 3. So when cos theta is 1 minus root 3 means root 3 or 1 minus cos theta is equal to root 3. Fine? 1 minus cos theta is equal to root 3. But 1 minus cos theta is twice sine square. Theta by 2 is equal to root 3. Means sine square theta by 2 is equal to root 3 by 4. This 2. This is root 3 by 4 or root 3 by 2, which is root 3 by or 2 raised power 1 by 2, 4 raised power 1 by 2. So this is 3 by 4 raised power 1 by 2. This is sine square. But what about sine? Sine theta is 3 by 4 raised power 1 by 4 raised to the power 1 by 2 on both sides. So what is theta? Theta by 2 sine inverse 3 by 4 raised power 1 by 4. So your theta is twice sine inverse 3 by 4 raised power 1 by 4. This is theta. Now you have already seen what is phi for this function. You have already seen what is phi for this function. So whichever is bigger, you have to take alpha as phi 1 minus phi 2 or phi 2 minus phi 1. Substitute value of theta, you will exactly get it as 3 sine inverse 3 by 4 raised power 1 by 4. Do it yourself because we have already done this question right now. Okay, now let me come to the problems of finding polar tangent, polar subtangent, polar subnormal. You see, there is nothing to be done more because what is, see, for example, let me tell you, what is length of polar tangent? It is r1 plus r d theta by dr whole square. What you need to know? You need to know r and d theta by dr. You can find both of these. What is length of polar normal? It is r1 plus 1 by r dr by d theta whole square. What is length of polar subnormal? It is r square d theta by dr by d theta. What is length of polar subtangent? It is d theta by dr. Simple, nothing to be worried about. You know everything. So let me just show you one question on this. Rest you will be doing on your own. Okay. Let me suppose that a question is there, 1 plus cos theta. Theta is tan inverse 3 by 4. You see, in every length, I need two things only, r and dr by d theta or d theta by dr. Now what is tan theta here? It is 3 by 4. What is tan? 3 by 4. So what this will be? Under root of 3 square plus 4 square, which is 5. So you can find sine theta is what? Perpendicular by hypotenuse. Cos theta is base by hypotenuse. So you know tan, sine, cos. You have dr by d theta. What is dr by d theta? Minus a sine theta. So you can find r. Fine. See, you have cos. What is cos? 4 by 5. 1 plus 4 by 5. So 9a by 5. Okay, you know the length. Dr by d theta. Sine. So minus 3a by 5. You know both these things you can find For example, let me find polar tangent. It is r 1 plus r d theta by dr whole square. Okay, now r is a 1 plus cos 4 by 5. So 9a by 5. Fine. Okay. dr by d theta minus a sine minus 3a by 5. 3 by 5a. So use it. R. What's R? 9a by 5. 1 plus R. What's R? 9a by 5. What is d theta by dr? This is dr by d theta. So d theta by dr will be 5 by 3a minus whole square. A 5 5 3 3. So 9a by 5. This is 1 plus minus 3 whole square. 3 9 plus root 10. 10. This is it. This is length of the polar tangent. You can always find other lengths also. So let me not discuss them. These are very easy questions. Let me find pedal. Let me take 1 or 2 questions for pedal equations. R square a square cos 2 theta. Yeah, or R equal to a raised power theta cot alpha. R and theta. Pedal equation. What is pedal equation? P equal R sine phi. Find the pedal equation. So relation between P and R. Phi, you know how to find phi. Phi is tan phi. Okay. Now, this is R. What is dr by d theta? A raised power theta cot alpha. And a raised power a theta is? So cot alpha. This is constant, right? Phi. What is tan phi? Because you know you need phi. What is tan phi? R d theta by dr. Your R is a raised power theta cot alpha. And this is a raised power theta cot alpha into cot alpha. So tan phi is tan alpha. So phi is alpha. Therefore, the pedal equation is P equal R sine phi. What's phi? P equal R sine alpha. This is the equation. P and R. Relation between P and R. Theta should not be there. Theta is to be eliminated, right? Now let me take one more question and we are finished with tangents and normals. No, I have to show you one more thing before finishing tangents and normals. A square cos 2 theta. I have to find relation between P and R. Okay, pedal equation. And I know P is R sine phi. I need to find phi first. So this is 2R dr by d theta 2a square sine 2 theta tan phi is R d theta by dr whole square. This I have already done. No? Cot 2 theta is tangent of 90 plus 2 theta. So your phi is 90 plus 2 theta. This is phi. Now what is pedal equation? P equal R sine phi. What is phi? Sine 90 plus theta. What is sine 90 plus theta? It is cos 2 theta. You know cos 2 theta. So this is P equal R. Cos 2 theta is R square by A square using 1. So my pedal equation is A square P equal r cube. Relation between P and R, no theta. This is Peter equation, right? Okay, I have to show you one more thing. If your x is a cos cube theta, y is a sin cube theta, you have to find Peter equation. See, you have relation in terms of x and y, Peter equation. You have to find Peter equation. Peter equation between, it is a relation between P and R. P is the length of the perpendicular. Is the right length of the perpendicular. R is the radius vector. But this is in terms of Cartesian form. Do you know what is length of perpendicular in the Cartesian form? You know, if you have a point, say x, y, x dash, y dash, what is the equation of the tangent? You know, if you have equation of the tangent, then what is length p? This you have to remember, and then you can solve these questions. You have to see it of your own, because this has been taught to you in your 12th class. I will be just using, you have to remember it once for your sake only. Now I have x equal a cos cube and y is equal r sin cube. I have to find relation between, I have to find Peter equation. Peter equation, relation between P and R. I will be using two things. P, length of the perpendicular from origin upon the tangent. Right? P and R, you remember that this is PR theta, this is the pole, this is R, and this is tangent. This is not an initial axis, this is the perpendicular from the pole on the, so I have to take length of this, length of P is length of the perpendicular from pole is 0, 0 upon the tangent. You know the equation, this has been done in your 12th class, and you know R. For R, since this is in terms of x and y, I know x square plus y square is equal to r square. When x is r cos theta, y is r sin theta. Conversion of Cartesian into polar, I have x square plus y square equal to r square. I will be using these two equations. Let me then solve one question. You will be solving other questions by using same method. Now you have x, you have y. What is dx by d theta? It is minus 3a cos square theta sin theta. Dy by d theta, 3a sin square theta cos theta. Fine. Now dy by dx, it is dy by d theta into d theta by dx. It is 3a sin square theta cos theta minus 3a cos square theta sin theta. What is that? Minus tan theta. Right? Cos, sin, 3a minus tan theta. What about this? Is dy by dx. Now, equation of tangent. Because I have to find equation of tangent, then and only then I can find P, perpendicular from the origin upon the tangent. This is the Cartesian form. Let me tell you again. This is Cartesian form. Okay? I have to find the perpendicular distance from the origin upon the tangent. So I have to find equation of tangent first. Equation of tangent at point x dash y dash, but x dash y dash is given, xy is given at a cos cube theta, a sin cube theta is what? Y minus y1, dy by dx minus sin theta by cos theta x minus x1. Fine. Y minus y dash is equal dy by dx at that point into x minus x dash. What is this? Y cos theta minus a sin square theta cos theta minus x sin theta plus a sin theta cos square theta, cos cube theta. Or what you have, x sin theta y cos theta is equal, see, I have taken it here, x sin theta y cos theta. Let me take this on this side, a sin square, it is cube, it was cube here, It was it cube or square? Square, I don't remember. Okay, a it was cube, a sin cube theta cos theta plus a sin theta cos cube theta. So it is a sin theta cos theta and sin square theta plus cos square theta, which is 1. So you have x sin theta y cos theta equal a sin theta cos theta. This is equation of the tangent. Now what is P? Now P, length of perpendicular from origin up to tangent. Tangent 1 है ये. Is P equal a sin theta cos theta divided by under root of sin square theta plus cos square theta. So your P is a sin theta cos theta. This is P. Fine. Now I have to find R. We know x square plus y square is equal to r square. Now what's x? This is your x, this is your y. So a square cos 6 theta, a square sin 6 theta is r square. Or a square, it is cos square theta whole cube, sin square theta whole cube equal to r square. Okay, now what is a cube plus b cube? A cube plus b cube, it is a plus b whole cube minus 3a square b minus 3ab square. You know this formula, I will be using this. This is your a cube, b cube. So this is a square, a plus b whole square, sin square theta plus cos square theta whole cube minus 3a cos square theta, 3a square cos 4 and b is sin square minus 3 cos square sin 4, 3a square b, 3ab square, right? This is 1, as you know, this is r square, This is r square, okay? Or you have a square This is 1 minus 3. You can take sine square cos square out. Sine square theta cos square theta. What remains is sine square plus cos square. It is 1. So this is 2. This was 2. Let me suppose this was 2 and this was 3. Or if it was 1 and it is 2, then from 1 and 2 I can find a relation between P and R, which is known as the Peter equation. From 1 and 2, I have a sine theta cos theta is, so I have a square 1 minus 3 see, from this sine theta cos theta can be written as P by A. So I will use it here. P square by E square equal to R square. From 1 and 2. Fine. So you have R square or A square minus 3P square equal to R square. This is the Peter equation. When the point was a Cartesian, in terms of Cartesian coordinates, I have found that a relation between P and R, which is known as the Peter equation. I can also find Peter equation when you have a question, say, in terms of Cartesian coordinates only. What you have to do, this is y. In terms of x, you have to find dy by dx. At some point, say x dash y dash. Find its tangent and then find p. Then use the formula x square plus y square equal to r square. Then a relation between p and r can be found. This is the way you have been taught in your 12th class also. So with this, I am finished with tangents and normals. I will be sending this video to you, and I will be sending another link where you can have, and I will be sending some questions for your practice also. Thank you very much.